take a look at these two molecules. Are they the same? Well, they have the same they have the same formula. That is a carbon that is bonded to an iodine, a chlorine, and a bromine, and a hydrogen. But they are not exactly the same molecule. You can't like put them on top of one another. So what are these two molecules called? These are called enantiomers. They are mirror images of one another, as you can see on this plane, but they are not superimposable. Means you can't stack them one on top of the other to get the same molecule. Another example of enantiomers in real life are your hands. Like, your hands are mirror images of each other, but they are non-superimposable. Like, you can't stack one of them. Like, you can't stack your thumb on top of your pinky and get... So, essentially, your thumb is not your pinky. So, enantiomers, what must they have? They must have something called a chiral center. So, in this context, for carbon, it must be bonded to 4 different substituents. So, like, let's say this carbon is bonded to a hydrogen, iodine, a chlorine, and a bromine. So these are 4 different substituents, which makes the molecule chiral. We makes the carbon chiral. So what if you don't have the 4 different substituents? Like, let's say this thing, right, is one hydrogen, another hydrogen, an oxygen, and a nitrogen. Well, it makes it non-chiral. Where's the mirror image? Fuck. Okay, oh, it's here. So this is the mirror image, right? As you can see, it's superimposable and you can stack on top of one another. Why? Because when a carbon doesn't have 4 different substituents, when 2 of the substituents are the same, you create something called an internal plane of symmetry. So for example, what an internal plane of symmetry is like, let's take a look at this, and let's say you have a scissors and you cut directly through this, you cut directly across this, like that, and the left side will equal to the right side. So that means it has an internal plane of symmetry. So this molecule is an internal plane of symmetry. So even a molecule is not chiral if it has an internal plane of symmetry. There's a difference between a molecule being chiral and a carbon being chiral. A molecule can have carbons being chiral, but it might not make the molecule itself chiral. We'll talk about that later. So now we move on from enantiomers to a different thing called diastereomers. Well, diastereomer is a very cool name, but it's quite a simple concept. So let's say we have this thing. This an alkene is a double bond. When you add chlorine across to an alkene, turns out you can have more than one product. You can actually form more than 2 products, but for simplicity's sake, I will only show 2 products. Your chlorine can add across the double bond, like this. You can add on one side, or wait, hold on. You can add on one side, or you can add on like opposite sides. So now we compare the 2 byproducts, like the 2 products formed. Like these 2 products, they are not mirror images of each other. As you can see, there is no plane of symmetry. Like, no matter how you turn it, there is no plane of symmetry here. But they are also not superimposable. That means you can't stack one on top of the other. So these 2 things are called diastereomers. Diastereomers are only useful when determining a reaction product. Yeah, so diastereomers, like I said, are molecules which are not mirror images of each other, and they are not superimposable. That's diastereomers, as you can see, like here. Okay, so the last thing is to illustrate the concept that a molecule is not chiral if it has an internal plane of symmetry, even though it can have chiral carbons. So for example, let's take this molecule, okay? This is the same molecule as this. The R just means that it can be anything. This molecule has 2 chiral carbons, as you can see here. This carbon is bonded to 4 different things: an oxygen, a sulfur, a hydrogen, and another carbon. So that makes the carbon itself chiral, means it's because it's bonded to 4 different things. And this carbon here is also chiral because it's bonded to 4 different things as well: oxygen, sulfur, hydrogen, and another carbon. But however, this molecule is not chiral. Why? Because it has an internal plane of symmetry. One thing that people keep missing out is that single bonds can rotate. So it can turn like this. So if it turns until like that, then you can realize that the bond has an internal plane of symmetry that you can cut the molecule here, and you have two of these, and there's an internal plane of symmetry. So this makes the molecule non-chiral. To prove this point, let's check if it has an enantiomer. So for an enantiomer, it needs a mirror image that is non-superimposable. So this is the mirror image of this enantiomer, as you can see. Of this molecule. Then you try to stack it on top of one another. Okay. See? You can stack the molecule. Means this molecule does not have an enantiomer. So this molecule is not chiral. Yeah, that's about it. So what we learn is enantiomers, diastereomers, and meso compounds. Oh yeah, these things are called meso compounds. They have chiral centers, but the molecule itself is not chiral due to an internal plane of symmetry. This is very important. This is the central rule of enantiomerism. Enantiomerism is essentially summarized with this. Okay, that's about it.